In this video, we are going to talk about number fifth property, and that is the closure property. It's really easy to understand. The word closure is basically derived from the word close. So let's see that what this property talks about. Let's try to understand this with the help of example. Let's suppose I have got a set, and set is that of the natural numbers. And natural numbers, as you all know, that it starts with 1. It is infinite set. That means it's a set of all the natural numbers. Now, if I pick any two numbers from it, let's suppose 3 and I pick up 5 and I add them together. So 5 plus 3 is 8. Now, if you notice that I pick 3 and 5 from this set, and the answer I got, that also belongs from the same set. So this is something which is closed under the same set, or which comes under the same set. So it shows that when you add two numbers together, the resultant or the answer that you get, it also belongs from the same set. Now here 3 and 5 belongs to the natural numbers. Both of them belonged to natural numbers, and the resultant also belonged to the natural numbers. So this is closed under the natural numbers. So you can say that this is the closure property of the set of natural numbers with respect to addition. But what if I change this sign with minus? So if I do so, then 3 minus 5 is negative 2, and negative 2 does not belong to the set of natural numbers. So you can say that closure property of the set of natural number is not valid. It is not valid for subtraction, because when we subtract two natural numbers, we do not get the result which belongs to natural number. So I hope that now you have an idea. So if you multiply, add, subtract or divide any two numbers or more than two numbers, and as a result you get another number which belongs to the same set, then that is closure property. And if you get the resultant number, and if you get the resultant value which doesn't belong to that set, then that is not closed. Let's see more. Now let's first see the closure property with respect to addition. Now let's assume this time the set of whole numbers. So as you know that whole number starts off with 0. So again, if I pick any of the two numbers, let's suppose 3 and 4. So if I add them together, so I get 7. So again, 7 belongs to the set of whole numbers. So addition obeys the closure property, or it is valid in addition. When you add two numbers or more than two numbers, you would end up getting the result which would belong to the same set. So you can write it as it's the closure property of set of whole numbers, because at this time we have whole numbers, of whole numbers with respect to addition. Now let's see for subtraction. If I take the same numbers 3 and 4, but this time if I subtract, then 3 minus 4, it would give us -1. Do you think -1 belongs to the set of whole numbers? No. -1 is basically, it belongs to a set of integers. So here we have whole number and the resultant is an integer. Then this is something which is not closed, right? So this is not the closure property. So subtraction does not obey the closure property because we don't always end up getting the same number. Yes, in some cases we can. For example, if I write it like this, 4 minus 3, then I would get 1. Then in this scenario, yes, it belongs to the whole number, but subtraction does not follow the closure property every time. So you have to be very cautious. Now let's see in multiplication. Let's assume the set of natural numbers. Let's pick any two numbers. Let's suppose 5 and 2. So if I multiply these two, which belongs to the set of natural numbers, so I've taken them from them. So 5 into 2 is 10. So 10 also is a natural number. So it belongs to the same set. So multiplication always obeys the closure property. So you can write it as, it's a closure property of set of natural numbers with respect to, since we have multiplication as our operator, multiplication, right? So it's a closure property of the set of natural numbers with respect to multiplication. If it would be whole number, we will always end up getting the number which belongs to the whole numbers. So this is always valid in case of multiplication as well. Now let's see in case of division. If I divide 5 by 2, so if I divide 5 by 2, then I would get 2.5. So 2.5 is not, it's not a natural number. Natural numbers are always solid, you can say, or they are whole. They are never in decimal form. So it is not a closure property. If I divide two natural numbers, so I end up getting decimal number, which is not a natural number. So division does not obey closure property, or closure property is not valid for division. So let's summarize a little bit. So closure property is the property in which you process two numbers and you get the number which belongs to the same set. So if you have natural number and as a result of processing you get the natural number, then that's a closure property. If you have integer here and as a result of processing you get an integer as a result, then it's a closure property. Another important thing is that it is only valid in case of addition and multiplication. That means whenever you add two numbers from the same group, you add or multiply two numbers from the same group, you would end up getting the number which belongs to the same set. If you are adding two whole numbers, you will get the result which also belongs to the whole number. And if you multiply two numbers, you would always get the result which belongs to the same set. Subtraction and division does not follow closure property always. So I hope that you have understood the closure property. Have a happy learning. Don't forget to like, share, and subscribe to our channel for more such videos.